Okay. Hello everybody. دي أول حصة في ال O level math. O level persistent كبر font. O level math. Cambridge and Edexcel. Okay. This is lesson 1. I already had انا الليسن دي كانت اصلا recorded على الزوم بس يوم السبت اللي فات the last Saturday, but it was very long عشان كان فيها اسئله كتير. I said I would re-record it and shorten the lesson عشان لو حد ما اتفرجش على lesson يبقى عنده sort of a short recording فيها الشرح كله سريع. Okay, in this lesson we will be discussing numbers. This is the first numbers, and specifically I'll be explaining the following. Okay, the definitions. Number 2, prime numbers. Number 3, HCF. Number 4, LCM. And number 5, your homework. Okay. طيب قبل ما أبدأ يعني I would like to ask a question. This number 2005, what does it represent to you? It's like your birth year, السنة اللي انت اتولدت فيها. Birth year. Or your balance. Or anything, anything. It's not important. But actually, عشان we humans reach this way of writing numbers, it took us ironically thousands of years. كتير يعني it was not until Muhammad ibn Musa al-Khwarizmi sort of standardized this way of writing numbers. يعني this beforehand يعني in زمان قوي كانوا مثلا عايزين مثلا يعدوا حاجه، مثلا كانوا بيعملوا حاجه اسمها تالي 1 2 3 4 5 1 2 3 4 5. they would come مثلا هنا 2 tallies so it's like 10. بس هو يعني the number system you see today actually emerged after thousands of years of trial and error. Thousands of years of experimentation يعني humans started to experiment with different number systems, and it was not until some sort of 850 يعني about 1200 years ago we got the final number system we use today. It's a quick brief history about number system بس عشان يعني it's good to know it عشان يعني to know what are numbers يعني the history of the number system you see today. So okay, let's dive deep بقى in the syllabus. Okay, definitions. Okay, for numbers, let's get a new page. Okay, new page, expand, let's change the color, draw. Okay, definitions of numbers. So we have different types of numbers, بس هما كل ال numbers بتدخل حاجة اسمها تحت real numbers. These are all types of numbers. We have something called rational numbers and irrational numbers. So natural numbers دول الأرقام numbers, let me change, numbers that can be written as a fraction irrational numbers, numbers that cannot be written as fractions. I'm a bit quick عشان انتوا I think you already know these stuff from previous years, فI'm just يعني explaining it quickly. Okay, ف natural real numbers يعني all types of different numbers can be either rational numbers or irrational numbers. Rational numbers can be divided into fractions or integers. Fractions like 22 over 7, 7 over 2, 15 over 6. These are fractions. Okay, or integers. Integers are whole number. Yani 0, that 1 minute. Integers like -5, -4, -3, 1, 2, 3, 0 هنا. 0, 1, 2, 3, and it goes on forever. هنا goes on forever. Goes on. Then the integers can be either, we have two types of integers. These are prime integers and composite integers. So prime integers, these are integers that can only be divided by themselves and 1. And these integers that are created, or we say composed from multiplying other integers. مثلا for example 12 is equal to 2 times 6, it's created from multiplication of 2 and 6. However, for example 17 is not created from anything. It's like 17 is equal to 17 only. It's not created, it cannot be created من البرودكت بتاع اي ارقام تانية. 17 is actually a prime number and 12 is a composite number. Okay, very good. It's a quick, we have real numbers. Real numbers can be either rational numbers, irrational numbers. Rational numbers, these are 22, these are rational numbers. They can be written as fractions, decimals, recurring decimals. And we have integers, which can be either prime integers or composite integers. There is another type called whole numbers. It's whole numbers. 1 minute, sorry, it's natural numbers, not whole numbers. Natural numbers. It creates from 0, 1, it's integers but without the negative numbers. 0, 1, 2, 3, 4, 5, up to infinity. So these are integers but not natural. These are integers but without the negative part of the integers. So let me delete it. Okay, very good. So moving forward, when we gave the example, we said that 12 is created from multiplying 2 times 6. So 12 is equal to 2 times 6. So we say that 2 and 6 are factors of 12. So we can also write 12 is equal to 2 times 6, and 6 is equal to 2 times 3. So we can write it as 2 times 6 or 2 times 2 times 3. So what is the difference between when we say 12 is equal to 2 times 6 and 2 times 2 times 3? So basically these 2 times 2 times 3 is called the prime factors. Prime factors. While 2 and 6 is called just factors. Because not all of them are prime factors. So these are all, 2 is a prime, 3 is a 2 is prime, 2 and 3 is prime. So all the factors are prime, so we call it prime factors. So let's put a rule in أي رقم, any number, which is not prime, can be written as a product of its prime factors. Think of a very big of any number, مثلا 999, 999. It can be written as 999 can be written as, if we divide it by 9, it will be, okay, 9 times 111. Okay, and 9 can be written as 3 times 3, so this is 9. And 111 is actually, let me divide it, let me get a calculator and divide it. Calculator. Okay. 111 divided 11, لا مش هينفع. divided 10 مش هينفع برضو. 11 divided 17 no. 15 no. 14 no. 111 3. Okay, if we divide by 3, it's 3 times 37, so this is 111, which is equal to 37 divided by 17 no. 17 divided by 4, 15, 16, 16. I got 37 divided by 7 divided by 4, 17 no, 18 no, 14 no, 37 divided by 19 no. So actually 37 is prime and 3 is prime, so 9 goes 9, 9, 9 is actually 3 times 3 times 3 times 37. So 1 minute, let me check that, let me assure that 37 is prime. 37 is prime. Yeah, 37 is a prime number. So Google actually helped me a lot. Thank you. Okay, so let's go forward. So factors 999 can be written as 9 times 11 times 111. So 9, these are called factors. And these are called prime factors. Prime factors. Okay, let's move forward. So any number, we can say composite number. Composite number. Composite. Which is not prime, can be written as a product of its prime factors, like what I've said. Okay, let's move forward. HCF, the highest common multiple, or actually called GDC, or greatest common divisor. These are the same thing, you know, highest common multiple, the biggest multiple in the number is equal to its greatest common divisor. These are the same thing. Type. Okay, we have, let's say we have 12. We want to know the highest common factor of 12 and 18. We want to know the biggest number that can divide both 12 and 18. The biggest number that can divide 12 and 18. Remainder هيبقى 0. So we have biggest number to divide. Let me see. Biggest. Let me change the color. Let it be. Okay, black is good. Biggest number to divide 12 and 18, and the remainder is 0. Okay, let's try and solve it. So let's put here 18 and 12. Let's try to divide it by different numbers. Divided by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. احنا مفيش رقم اكبر من 12 عشان we can divide 12 by a number which is greater than 12. Therefore 12 is the maximum. We'll stop here. Okay, let's try. Let me get the bread. Okay, 18 divided by 2, it's 9. 18 divided by 3 is 6. 18 divided by 4 is 18 over 4. It's a fraction. 18 divided by 5, it's a fraction. 18 divided by 6 is 3. 18 divided by 7, 18 over 7. 18 divided by 8 is 18 over 8. It's a fraction. 18 divided by 9, it's 2. 18 divided by 10, it's 18 over 10. Then 18 over 11. Then 18 over 12. These are all fractions. Okay, so 18. Okay, we finished with 18. Let's see 12. 12 divided by 2 is 6. 12 divided by 3 is 4. 12 divided by 4 is 3. 12 divided by 5 is 12 over 5. It's a fraction. 12 divided by 6 is 2. 12 divided by 7 is 12 over 7. Then 12 over 8. Then 12 over 9. 12 over 10. And 12 over 11. 12. 12 divided by 12 is equal to 1. So let's go back to the definition. Biggest number to divide 12 and 18, and the remainder is 0. So the biggest one, so if anything that doesn't have a remainder 0, so let's remove all the fractions. Okay, remove this, remove this, remove this, remove this. Also remove this because it's a fraction. Here, okay, and remove this. And remove this because there's a fraction here. The biggest number, 2 is not the biggest, 3 is not the biggest, and 6 is the biggest number. So the HCM of 18 and 12 is equal to 6. So الطريقة دي صعبة شوية. It's a bit cumbersome to solve it this way. Let's try to get a simpler way. So if we wrote 18 and 12, 18 is equal to 6 times 3, and 12 is equal to 6 times 2. So basically, we get the common factor, and this is equal to HCM. Let's say common factors, because if we said 6 times 3 is equal to 2 times 3 times 3, and this is 6, 2 times 3 times 3, so times 2. So the common factors are 2 and 2, and 3 and 3. So this is 2 times 3. Okay, so therefore HCM is the product of the common factors. Okay, let's take another example. Let's get the HCF of 24 and 18. So 24 is equal to 4. let me write it. 4 times 6 is equal to, and 4 is equal to 2 times 2 times 2 times 3, and 18 is equal to 3 times 6. From here you can know that the HCM is actually 6, but let's do the prime factors of it. Okay, is equal to 6, so it's 3 times 2 times 3. So we get the common factors. All the common factors we factor them out. هيبقى هما ال HCF بتوعي. فcommon factor تبقى هنا 3 is common, 2 is common. Notice now we take each one, يعني each we take 2 هنا وهنا, we take 1 2. We only take 2 times 3. We will not take these ones. We will not take them. We only take common and we take it one time. For each common thing we take it one time. So it's 2 times 3, so the HCF is equal to 6, as you can see here. A minute. 6, which is equal to 2 times 3. We did not take the these 2's because they only appear one time. They are not common between the two factors. We take the common factors. Common factors only once. Only once. Now let's say only, يعني the number of times they appear in both numbers. The number of times they appear in both numbers. Okay. Let's take another example. 12 and 16. 12 is equal to 2 times 2 times 3, and 16 equal to 2 times 2 times 2 times 2. So the HCF of 12 and 16 will be equal. You will take the common factors. Okay, 2 and 2, then 2 and 2. So the HCF is equal to 2 times 2, which is equal to 4.
Here's what I found.
Oh, okay, so Google Assistant found the HCF. Very good. Okay, we are done. Okay, let's have another harder example. The HCF of 13 and 17. ممكن تفكروا فيها شوية. 13 and 17. Actually, 13 is prime. It cannot be written as a product of prime factors because it's prime. It doesn't have prime factors. Let's say no prime factors. No prime factors. And so no prime factors. So HCM does not exist. Or actually, HCM of 13 and 17 is 1. 1 HCM of 17 and 13 and 17 is 1. There is the greatest common divisor of 17 and 13 is 1. You can say 13 over 1 equals 13 and 17 over 1 equals 17. So the HCF of 13 and 17 is 1. Okay. The last thing we're going to see today is the LCM. Actually, this question is in the homeworks. يعني I just cheated you. فمش مشكلة. The least common multiple. Okay. this is the last thing I will say today. So let's say we want to divide 2 over 2. We want to add 2 over 21 plus 1 over 6. What would you do? You have to get the common denominator, right? Which is the LCM. So we're going to get the 2 over 21 plus 1 over 6 will be equal to 42 times 2 times 2 times 7 times 7 to 42. 4 plus 7 will equal 11 over 42. Okay. So the least common multiple is the smallest multiple of 2 numbers or 3 numbers or 4 numbers. This is the smallest common multiple in of these numbers. Let's try to calculate the LCM of let's take the easy example of 21 and 6. So 21 is equal to 3 times 7 and 6 is equal to 3 times 2. LCM we factorized, we will take all the uncommon factors. 7 is an uncommon factor, 2 is an uncommon factor. 2 times 7 uncommon, common factor, uncommon. Let me write it clear عشان تبقى واضحة. Uncommon factor. These are uncommon factors. Okay, and for the common factors, we will take the number of times it appears most. For example, 3 appears one time. 3 is appear one time. But therefore, we will take it one time because it appears to one time in both cases. So 2 times 7 equals 14 times 3, which is equal to 42. Okay, let's get another example. LCM of 16 and 12. So 16 is equal 2 times 2 times 2 times 2, and 12 is equal to 2 times 2 times 3. So, okay, we get the number of times, so we factorized, we get the uncommon factors. 3 is uncommon factor by LCM 16 and 12 to be equal 3 times. Here 2 is a common factor, but 2 appears in twice. 2 appears twice. Let me change the color. Appears twice. Appears 4 times. So we will take these 4 times and put them in the LCM. It'll be 2 times 2 times 2 times 2. 3, which will be equal to 3 times 2 is 6 times 4 times 8 equal to 48. So LCM 16 and 12 is equal to 48. Okay. Let's try to put some way to find the LCM, a sort of way to find LCM. Number 1, factorize, or let's say get the factors. Let me change the color. A way to find LCM. Number 1, number 2, number 3. 3 steps. Get the factors of each number. Then take all uncommon factors. Then for common factors, see the number times it appears in each number. Let's count the number of times it appears. Count the number of times it appears in each number and take the greatest. For example, in 16 and 12, here 2 appeared 4 times. Two appeared 4 times, and here 2 appeared 2 times. So I'll take 2. I'll take 2 4 times. Then 3 appeared. 3 is an uncommon factor, so we just took 3. So the LCM will be 48. I think I'm done. I'll put another examples. I try to make this video as short as possible. The iPad will مفيش صحن فمحتاج اقفل دلوقتي. I'll put the Telegram channel, the link for the Telegram channel in the description, and I'll put the lecture notes and the homework I'll post them in the Telegram channel. So thank you for watching. Hope you understood the LCM and HCM and understood the numbers definitions, and see you soon inshallah.